Okay, good morning, welcome to
SuperMath number 41.
SuperMath41. Take a step away from the shadow. We've got fun little problems from Art of Problem Solving's Geometry book, chapter 5.4, and it's actually problem 5.4. And the reason we're doing this problem is because it's we have a different solution than the book had, and I thought our solution was pretty cool, so it'd be fun to talk through. Our solution is to part B of the problem. The problem is drawn up and it's a little complicated. We have two big triangles, P, Q, R, and then Z, Q, W, and we're told that P, Q, and P, R have the same length. Then some other things get drawn in part A, actually also in the beginning of the problem. Z, X is perpendicular, Q, Y is perpendicular up there, and they're parallel. And we learn a bunch of angles are the same. This angle and this angle are the same because of the isosceles triangle. This angle is the same as that angle because of opposite angles.
Yep.
And that means this triangle, ZWQ, is the same as similar, thanks, to ZXR and QYR. But the thing it asks us to show in the star problem in part B is that QY is equal to ZX minus ZW. So that's fascinating. Fascinating. So go ahead. How did we approach that?
Well, we drew this line and then made a perpendicular one. So these lines meet at a right angle.
Okay, great.
And I'll call this point A.
We use A? Oh, no? All right, good. Okay.
So, if we could prove these triangles were congruent, that would be a help.
That would be a big help, yeah.
This triangle QWZ and triangle QAZ.
Yep.
So, well, they share a hypotenuse, we know.
Okay, so those triangles, QWZ and QAZ, share two things for sure. They share this line, QZ.
And they share this angle.
They share two right angles. So what you said is right. QZ is a hypotenuse for two different right triangles. Does that mean those triangles are the same?
Well, we don't have enough angles to do that yet.
Right, we just need to find one other angle in this triangle, ZAQ, that matches an angle in the triangle QWZ. And what is that angle?
Well,
what can we say about that angle?
That angle is equal to this angle.
Right, that angle is equal to angle 2 by the
opposite
angles and intersecting lines rule. So now we know these two triangles are what?
Are congruent.
They're not just similar.
Because they share the hypotenuse, so they have to be congruent.
They're similar because they share all three angles. They're congruent because one of the sides is the same.
And then we get this whole angle is angle 1.
Yep. Okay, and now how does this help us show that QY is the same as ZX minus ZW?
Well, we can have QY, we can have the full thing.
Okay, which is what?
YA.
Alright.
Well, YA is the same. We can split YA into YQ and QA. YA is YQ plus QA.
Alright.
And QA is WZ.
Okay, QA is WZ. Alright.
So, and YQ is XZ.
What?
Wait. YA is XZ.
Why is that?
Because these lines are parallel.
And what shape did we make when we drew this right angle in here?
We made a rectangle.
We made a rectangle. Okay. So YA is equal to ZX or XC.
ZX is YQ plus WZ.
Okay.
So now we just have to flip this. I'll bring the, so we have ZX minus WZ is YQ.
Very good. Yeah. ZX minus WZ, which is the same length as ZW.
Yeah, it's
Equals
just,
YQ, which is the same length as Q1. Okay, so drawing in these extra lines basically was a miracle, right?
Yeah.
It solved right away. And a lot of times in geometry you're going to see that. If you can just find the right extra shape to draw in, you can get the relation you're looking for. For homework, I'm going to have you walk through their solution, which is different and doesn't involve drawing in an extra couple of lines. But anyway, good job. Good job this morning. That is a very challenging geometry argument.